Okay, before we start solving this problem, I'm going to share my screen and go to Desmos so you can see a little trick that might be beneficial. Here I am on Desmos, and I've actually entered the function as f of x equals, there it is. And I can use the Desmos derivative operator to say that g of x equals the derivative of f of x, which there's the graph of g of x. And then I type in the answer that I got as k of x and see if they match. That's kind of a way to check to see that I solved the problem correctly. And as you can see, it looks like that is the answer. 12 times, well, question is, where did I get that 8x minus 3? So let's go back to Desmos and see if we can figure out what happened. So to get to the second line, I use the chain rule. I thought of f as 4x minus 5, the quantity to the third power, and g is the quantity 4x plus 2 to the third power. And I think first times the derivative of the second plus the second times the derivative of the first. When I take the derivative of the second function, I use the power rule followed by the chain rule. So I reduce that exponent by 1, multiplied by the derivative of the inside. Similarly over here. Now on a multiple choice test, you might be asked to come up with a simpler version of this. And the idea is that I'm going to factor out from both sides of this plus sign the greatest common factor of each of these terms. So I can see that there's a 3 and a 4 in both terms, which is 12. And I can see that each term has a 4x minus 5 to the second power. And each term has a 4x plus 2 to the second power. And what's left inside the parentheses or brackets from each of those terms separated by the plus sign? Well, from this first term, I factored out everything except the 4x minus 5. And from the second term, I factored out everything except a 4x plus 2. So the expression in the brackets is 8x minus 3. And that might be an answer on a multiple choice test. And of course, at some point in time, you're going to be using this derivative for something. And we might want to know, when does the first derivative equal to 0? When it's written like this, it's easy to tell. When x equals 5/4, when x equals negative 1/2, or when x equals 3/8. Okay, there you go.